Lesson 5, Mixed Operations in Rational Expressions. When simplifying rational expressions with mixed operations, order of operations is to be followed. Example 1. We have two operations, addition and division. And using BADMES, we know that we have to divide first. So I'll put the brackets around these two terms, and then we'll try to factor as much as we can. The denominator here can be factored. It's 1, 1, 4 times 5. And because the middle term is negative, I want to keep the 5 negative, and we'll keep the 4 positive. When we cross multiply, we get negative 5 plus 4, which equals negative 1, and it's correct. So let's rewrite it. First term stays the same. Second term stays the same as well. And then we change the operation into multiplication, and we reciprocate the second term. So we have x plus 4 times x minus 5 all over x plus 6. And then we can cancel x plus 4 on the top and the bottom. And we're left with x plus 5 over x plus 6. And then plus x minus 5 all over x plus 6. And because now we have a common denominator, I can just combine the numerators together. We have x plus 5 plus x minus 5 all over x plus 6. These cancel each other out. We are left with 2x over x plus 6. And so we also need to restrict the x. So we also call it non-permissive value. So x cannot equal to negative 4. X cannot equal to 5 from here because we used to have this in the denominator somewhere. And then lastly, we have negative 6, which comes from this denominator. Part B. We have addition, we have the brackets, and there's a hidden multiplication in between here. So using the order of operation, we know brackets comes first. So we need to simplify the inside the bracket. Let's just first factor what we can. The first term denominator is equal to x plus 3 times x minus 3, because this binomial is in the form of difference of squares. And the second denominator here would be 1 by 1, 3 by 3. So when we cross multiply, we get 3 plus 3, which is 6. And this equals to the middle coefficient. So this is correct. So we'll just put the brackets around and we'll rewrite it. The original expression becomes x minus 3 all over x plus 3 times x minus 3 plus x plus 3 all over x plus 3 times x plus 3 all inside the bracket, and there's second term to multiply. Let's cancel out common factor, this one. So we are left with 1 over x plus 3 plus 1 over x plus 3 inside the bracket, and we're multiplying by the second term. And then I see a common denominator, so I can combine the numerators together. We will end up with 2 over x plus 3 times x plus 3 all over x plus 1. And then we can cancel the x plus 3, and we're left with 2 over x plus 1. Before we move on, we do need to state the non-permissive values. So x cannot equal to plus or minus 3 from this. So x cannot equal to negative 1, and this comes from here. Before we move on to example 2, I would like to quickly go over what complex fractions are. So complex fractions are the rational expressions that contain fractions in the numerator and or the denominators. So it would look something like this in the numerator and this in the denominator. So in order for you to solve complex fractions, we do have to follow a couple steps. First step would be to get a common denominator for the numerator, then the denominator of the complex fraction. And then you're going to write that as one fraction. And finally, rewrite the division in a side-by-side manner and then simplify. So let's try this. It looks like on the numerator, I only have the fraction portion here. So it's pretty easy to state our common denominator. We can just stick to y and y. And this is only for the numerator. And then we have 2y on the top and 4 for the second term. So we're done with the numerator. Now let's take a look at the denominator. Again, I only see the denominator here, so we'll just keep the y as our common denominator. So the first term becomes y squared, and we stay with 4. Now that we have a common denominator, we can just combine those numerators together. We have 2y minus 4 all over y, and huge fraction bar, and then y squared minus 4 all over y. Rewrite this side by side. 2y minus 4 over y divided by y squared minus 4 all over y. If we're dividing a fraction, then we need to switch the operation to multiplication, and then you have to reciprocate the second fraction. It says we need to simplify further, so we can factor this one and this one, but also I can cancel out the y's on the top and the bottom. So let's see what I can factor out. I can factor the 2 out. We're left with y minus 2 all over. This one is difference of squares, so y plus 2 times y minus 2. And then we could simplify further by canceling these two. And then finally, we are left with 2 over y plus 2. So non-permissive value would be y not equal to plus or minus 2 and 0. Example 3. Simplify and identify all restrictions. So this is a complex fraction. So first we will have to find the common denominator for the numerator portion. And it looks like LCD, the lowest common denominator, would be 5x squared. So I'll multiply x top and bottom for the first term, and then I'll multiply 5 top and the bottom. So if we were to rewrite it, we get 2x over 5x squared minus 15 over 5x squared. Now let's take a look at the denominator. Note the lowest common denominator would be 4x squared. So I will multiply the first term by 2x. And then you do the same thing for the top. And then I'll leave this alone because the denominator didn't change. So let's rewrite it. We have 4x squared, 14x plus 3 over 4x squared. All right, it's time to write this side by side. We have 2x minus 15 all over 5x squared divided by 14x plus 3 all over 4x squared. There's a division, and then we have a fraction here. So let's switch the operation and flip the second fraction. Like this. And then see what we can cancel out. I could cancel the x squared out. And that's about it. We can't really cancel anything out. So we have 4 times 2x minus 15 all over 5 times 14x plus 3. And the non-permissive values are when x equals 0 and x equals -3/14. And this comes from here. Now let's take a look at part B. The lowest common multiple of the numerator would be x minus 1 times x plus 2. So we have to multiply x plus 2 to the first term, and on the top and the bottom. And then for the second term, I'll multiply x minus 1 to the top and the bottom. I'm just going to first rewrite it. X plus 2 all over x plus 2 times x minus 1 plus 2 times x minus 1 all over the denominator here. And then I'll take a look at this portion. It looks like I have to multiply x minus 3 to the first term to get the lowest common denominator. And then we multiply same thing on the top. And for the second term, I need to multiply by x plus 2, top and the bottom. So this is all over 2 times x minus 3 all over x minus 3 times x plus 2 minus x plus 2 all over x minus 3 times x plus 2. And then we're going to rewrite this side by side. We'll first combine these two together because now they have a common denominator. We have x plus 2 plus 2x, so expand, and then -2 all over x plus 2 times x minus 1. And then multiply by, flip the second fraction. So we have x minus 3 times x plus 2 on the top, and then we have 2 times x minus 3 minus x plus 2. Let's actually factor this one out once more. We have 2x minus 6 and then minus x minus 2. So let's reduce what we can. So I can cancel the 2 here, and I could remove these two for now. All right, so we have 3x over x minus 1 times x minus 3 all over x minus 8. Okay, looks like I can't simplify any further, so this is equal to 3x times x minus 3 all over x minus 1 times x minus 8. Non-permissive values are 1, 8, -2, and 3. So this is it for lesson number 5. I'll see you guys in the next video.